In this video, I'm going to show you how to do evaluation of expression or how to evaluate an algebraic expression. And for this, I'm going to show you the mnemonic, the most common mnemonic that we use to teach this, which is PEMDAS, right? PEMDAS, it's an acronym, so each of those letters tells us which is the first operation that we have to do or simplify in an expression that we are evaluating. So P stands for parentheses. So this means every operation that is inside the parentheses. So if I have something that looks like this, 6 minus 3, I have to do first. Okay, people tend to confuse that with parentheses or numbers inside the parentheses. So you have to be careful. This is not an operation inside the parentheses. This will count as a multiplication. So you will have to do that operation later on. So any operation inside a parenthesis, if I have 10 divided by 5 inside a parenthesis, then those take priority in PEMDAS, right? This one over here in the middle does not take priority. The next letter in PEMDAS, E, stands for exponents. So exponents are those small numbers that are superscript to letters or to numbers. So then we have to evaluate this operation. So for example, 5 to the power of 2 or 10 to the power of 3. So those small exponents, if I have a number inside a parenthesis that's negative 10 to the power of, I don't know, you can come up with any exponent, then I have to perform this operation, the exponents, only after I'm done with all of the operations inside a parenthesis. The next operation, the M, stands for multiplication. So the multiplication signs, every multiplication that you have, you might encounter those multiplications as two numbers inside a parenthesis, but this is a multiplication. There's no operations inside the parenthesis. Of course, you can also use the dot notation, 2 times 3, and the times sign. We don't really use this one because we might get this confused with an X. So try to avoid the use of this symbol, even though this is a multiplication. Try to avoid the use of those symbols. And then after you're done with the multiplications, now you have to do any divisions. So the divisions, they can appear with the common division sign. They can appear as the diagonal, that also means a division. They can also be inside a parenthesis, right? Well, that will be in P as in PEMDAS, but this is a division. And then AS, those are going to be additions and subtractions. So any addition or subtraction, right? 10 plus 2, all of these operations are going to fall into addition subtractions, okay, from PEMDAS. So the first thing that we do is parentheses, and then we have to do exponents. And then the rule is doing multiplications and divisions left to right, and then addition subtractions as they happen left to right. So let's follow these instructions and try to simplify one expression or evaluate one expression. So my expression is going to look like r cubed minus 2 times 6 minus r to the power of 4. So this is my expression, and I have to evaluate this for r equals 3. What this means is that I have to take the number 3 and replace every letter r in my original expression for number 3, and then do PEMDAS to this, right? I'm going to write here PEMDAS so that we can remind ourselves of the order of operations. So I'm replacing every single r for a number 3. What I like to do is I like to replace those letters for, instead of putting 3 in there, I'm just going to put an empty parenthesis. So I like to replace those 4 parentheses first, just the letters, not the signs or any other number, but just the letters that I have in this operation I'm going to replace for a parenthesis. This is so that I don't miss any signs, because it's really, really common. So for example, if this r, instead of being equals r equals to 3, it will be r equals to negative 3, then it will be a little bit common to lose that negative sign in the operations. So what I like to do is I replace all of the letters for a parenthesis first, so those small parentheses that I put in here, and then I'm going to plug in the number that I am substituting. In this case, the number that I'm substituting is 3, so I'm replacing all of the r's that I have in my expression for number 3, and then I have to follow or do PEMDAS to this expression. So I'm going to do all of the operations left to right, okay, as they happen. So starting with parentheses, I have to perform operations inside the parentheses, and the only operation inside a parenthesis that I have right now is going to be 6 minus 3. That is inside a parenthesis. This is not inside a parenthesis. This is a number that has an exponent, right? So this second expression, this is an operation inside a parenthesis. I have a big parenthesis and I have a subtraction inside. Of course, inside of the big parenthesis, you also have to follow PEMDAS, but since the only operation that we have is a subtraction, you don't really have to worry about it. Okay, so that's the operation that I'm going to do. I'm rewriting everything. So that's 3 to the power of 3 minus 2. And I'm going to do the operation. So 6 minus 3 is going to be 3. And I leave the exponent in there. So I haven't done anything but the operation inside the parentheses in PEMDAS. Then I go back and check to see if I don't have any more operations inside the parentheses. And the reality is that I don't really have any more operations inside the parentheses. This is an exponent. That's just the number 3 inside the parentheses. That's just the number 3 inside the parentheses, so they don't take place in the PS in PEMDAS. The next operation that we're going to do is going to be exponents. So now I'm going to move into exponents, those small superscripts that I have on the numbers, and those exponents apply only to whatever's in front of those exponents. So it looks like the first expression is 3 to the power of 3, and the next expression that I'm going to do is 3 to the power of 4. Because we are doing exponents, we cannot do multiplications. It is really tempting to do 2 times 3 over here, but it doesn't take priority yet. We have to follow PEMDAS. We are doing exponents. So let me go ahead and evaluate the first expression, 3 to the power of 3. A common mistake is that people say this is 9, they multiply 3 times 3, but this is not what an exponent means. What an exponent means, it's a repeated multiplication. So what this means is that I'm taking 3 and multiply times itself 3 times because that's my exponent. On the other operation, I'm going to take 3 and multiply times itself 4 times because my exponent is a number 4. This is what the exponents mean. And this is the operation that I'm going to do. So for the first multiplication, or the first exponent that I have in there, 3 to the power of 3, that's going to be 3 times 3 is 9, and 9 times 3 is 27. So this is going to be my result for the first exponent. I'm going to leave this number 2 over there, and I'm going to do the next exponent, which is 3 to the power of 4. That means, again, 3 times 3 times 3 times 3. So 3 times 3, that's 9. 9 times 3, that's 27. And 27 times 3, that should be 81. So the result of 3 to the power of 4 should be 81. That is my operation. I'm done with the exponents in PEMDAS. So the next operation that takes priority over here in PEMDAS is going to be multiplications. So now I have to do any multiplications that are available. And it looks like I have a subtraction over here. I don't have to do that. Still no time to do that subtraction, but I'm going to do the multiplication. Remember that if you have a parenthesis by itself or a parenthesis with something in front of it, that means a multiplication. So that is the next operation that I'm going to do. Negative 2 times 81. So 27, that I'm going to leave in there, and I'm going to multiply negative 2 times 81, and that should be negative 162. So I'll perform all the multiplications. The next step in PEMDAS, divisions, which I don't have any divisions, additions, which I don't have any additions, and now the last thing that I'm going to do is going to be the subtraction. So I take 27 and subtract 162, and the result should be negative 135. So this is my result for evaluating this first expression that I have in here. So let's take another example. Let's evaluate a different expression. What about something that looks like 23 minus 0.12x? So this is my algebraic expression. I'm going to evaluate this for x equals 10. So I'm replacing every single x for a number 10. And then I'm going to do PEMDAS to this. PEMDAS. So let's do the first step. I'm going to replace every single x that I have for a number 10. Remember that the best way to do this is to replace the letter for a parenthesis, and then inside the parenthesis you can substitute the number that you're working with. Okay, so let's do PEMDAS. It says the first thing is operations inside a parenthesis, and I don't have an operation inside a parenthesis. Over here, all I have is a number 10 inside the parenthesis. Okay, so we don't have operations inside a parenthesis. We don't have exponents, those superscripts that I have on the numbers. They're not available in this algebraic expression. And then multiplications. Now I have to do multiplications. I don't do the subtraction yet, even though it's tempting. We're not doing that, we're doing the multiplication. So negative 0.12 times 10. This is the multiplication that I'm doing. So 23 stays in there. A negative times a positive is going to give me a negative result. And 0.12 times 10, that's going to be 1.2. There's no divisions, there's no additions, and the last operation that I'm going to do, of course, the only operation available is going to be the subtraction. Now I'm going to subtract 23 minus 1.2, and this should give me 21.8, and this is going to be the result. If you try to do a different order of operations, let's say you do the subtraction first and then you multiply times 10, this is going to give you a wrong result, something completely different, completely off. So you always have to follow PEMDAS, which is parentheses. First we start with parentheses, then exponents, then multiplications, divisions, and then additions, and then subtractions. Okay. So the last example that I'm going to do, it has all of the operations available in PEMDAS, or most of the operations available in PEMDAS. So this looks like 8 plus 6 times x minus 3 to the power of 2. And we are evaluating this expression for x equals 13. So let's see what the result is if I take 13 and substitute it into the x that I have in my expression. That's 8 plus 6, and then I'm opening parentheses. I'm putting a small parenthesis in here for the letter. Subtract 3, close parenthesis to the power of 2. I am replacing all of the x's for a number 13, and now I have to do PEMDAS again. PEMDAS. So operations inside a parenthesis. And this I do have an operation inside a parenthesis, which is 13 minus 3. So this is the first operation that I have to do. So we don't do 8 plus 6, even though it's tempting. We don't do that yet. We just do 13 minus 3, which is going to be 10. And we still have an exponent outside of this parenthesis. Okay, so next thing that we're going to do, we don't have any more operations inside a parenthesis. So now we have to do exponents. Okay, so let's go ahead and do this small exponent that I have outside the parenthesis. That is an exponent of 2, which means I'm going to do a repeated multiplication of the number inside of the parenthesis 2 times. So 8 plus 6, we don't do this yet. And now I'm going to do the exponent. So that means this exponent over here means 10 times itself 2 times. So 10 times 10, that's going to be 100. This is the result of doing the exponent. We don't have any more exponents around, so now we have to move into multiplications. We're following PEMDAS, so we have to do the multiplication available. We don't do 8 plus 6 yet, even though it's tempting. So let's go ahead and do this. So the multiplication that I'm doing is 6 times 100. 6 times 100, that's going to be 600. That is almost the last operation. Now I have to do divisions if there's any, and then I have to do additions and subtractions as they happen left to right. And that's the last operation that we're going to do. So 8 plus 600, that's 608.